Okay, the objective for this video is I can find the rate of change of a linear relationship. And this is the Greek symbol delta, or Greek letter delta, and it means change. So when we're finding the rate of change, we do the change in y divided by change in x. We write it as this. So that means the change in the y value divided by the change in the x value. And a function is linear if the rate of change is constant and the graph is a straight line. So we'll do a couple of examples to look at what that looks like. So if this is our x value and this is our y value, we want to find the change in y, there it is, and divide it by the change in x. So the change in y, this is going up by 4, 64 to 68 goes up by 4, this goes up by 4, this is going up by 1s every time. So remember, it's change in y divided by change in x. So we do each row. So 4 over 1, 4 over 1, 4 over 1. Since it was always the same, we say the rate of change is constant, so I know this one is linear. Sorry, I think I skipped the directions for these problems. It says determine whether the relationship is linear. If so, find the constant rate of change. If not, explain your reasoning. So this one is linear, so you have to state what the rate of change is. The rate of change is 4 degrees Fahrenheit per minute. So the temperature is increasing 4 degrees per minute. For this one, we're going to do the same thing, x and y. This one's going up by 10, this one's going up by 90, this one's going up by 40, this one's going up by 5, 5, 5. And then we do change in y divided by change in x. So for this row it's 10 over 5, which simplifies to 2. For this row it's 90 over 5, which simplifies to 18. For this row it's 40 over 5, which simplifies to 8. So since it's not the same, it's nonlinear, because the rate of change was different every time. There's no constant rate of change. And then I have to explain why. The rate of change is not constant. Okay, let's go on to the third and the fourth one. So we're going to do the same thing. This one is x and this one is y. The change here is up 20, up 30, and then down 20, so I'm going to use a negative 20. Then the change here is 5, 5, and 5. So I have 20 divided by 5, which is 4, 30 over 5, which is 6, and negative 20 over 5, which is negative 4. And since these are not the same, then it's nonlinear. So I'll say this one is nonlinear because the rate of change is not constant. Okay, and then we have one more. This is our x value. This is our y value. This is going up by 20, up by 20, up by 20. This is going up by 2, up by 2, up by 2. So we check every one. 20 divided by 2 is 10, 20 divided by 2 is 10, 20 divided by 2 is 10. So we would say this one is linear, and the rate of change is $10 per hour. Okay, we're going to use our other definition of linear when we're doing these bottom three problems. It says, determine whether the relationship between the two quantities described in the graph is linear. If so, find the constant rate of change. If no, explain your reasoning. So if it's a straight line, then we know it's linear. So I know this one is linear, and now I have to find the rate of change. So I'm going to use two dots. I'm going to use the two dots that are already labeled for us. And we're going to do the same thing, change in y divided by change in x. So the change in the y value is the change in how far up or down it's moving. So from this dot to this dot, it goes 1, 2, 3. It goes down 3. So it's going to go down 3, so I'm going to use a negative 3. And it goes to the right 1, 2, 3, 4. So the change in x is 4. The change up or down is the change in the y value. The change right or left is the change in the x value. So it's linear. The rate of change is negative 3 over 4, and I should add units. It's negative 3 inches in 4 days. So this vase is losing 3 inches of water every 4 days. This one is not a straight line, so we'd say it's nonlinear because it's not a straight line. And then this one is linear because it's a straight line, so I have to find the rate of change. So I pick any two dots. If I pick these two, it goes, I'm doing change in y over change in x. It goes up 2 boxes, but it goes up from 1 to 2. It only goes from 1 to 2. So it's going to be going up 1, and then to the right goes from 4 to 8. So it goes to the right 4, even though it goes over 2 boxes. It goes from 4 to 8. So it's going up 1 foot every 4 hours. So the snow is increasing by 1 foot every 4 hours.